try that again. Let's see. There we go. That's better. Now I'm actually streaming. Okay. So, let's see. This I actually want to set to something a little less likely to break stuff. That'll do. Okay. Perfect. Awesome. All right. So I need let us see. Let the people in Discord know. There we go. Okay. All right. I think that should work fairly well. It's been a while since I streamed, so everything's kind of a mess. I've switched operating systems since last time too. Let's see. Can I want to add a browser doc. How do I do that? Oh well. All right. Let's see. Okay, so first thing, let's get my I want to get this to a readable scale. Let's see. Folder settings. Font size, let's go. Let's try 32 and see how that looks. That is very large, but it should be fairly readable on stream. Maybe we go 28. Somewhere in the middle there. Because I'm used to relatively small text when I'm doing it by myself, but that should be fairly readable for stream, I think. So, what type of language are we going to be making? That is the question. So, my first thought is that, let's see, it's going to be a concatenative stack-based language. Some other languages that is similar to would be like Porth. There are a few others. Joy, Factor, Kitten. You know, it's a relatively uncommon type of language, but it's been around for ages and it's super easy to make and use. It's just a little bit of a weird, because it typically uses reverse Polish notation. So, for example, instead of 2 plus 2, in this kind of language you would write 2 plus, which basically is just a product of how the language is executed. And I'll go into that in a little more detail soon. Similar to languages like Porth. And let's grab let's just grab you like so. And I will paste that in the chat as well. Boop. It's heavily inspired by Tsoding's Porth project, but I'm going to be taking a bit of a different approach. It's going to be a bit more high-level usability versus low-level performance and direct compilation. And let me grab Porth's link as well, because I am taking a lot of inspiration from Tsoding. If you haven't watched his streams, I highly recommend them. They're very entertaining, very educational. He does a great job. So what will we be starting with? Okay, so the basics of what we're going to be doing here is I have nothing planned out for this language beyond like the very basics of what I've just written. So I'm going to, I guess my first step really is to just start implementing a basic Lexer and see where that takes us. Yeah. So the question is, what language do I want to implement this in first? Because eventually I would like to maybe bootstrap this, but that's way down the road. So let's actually get a bit of a task list going. So just start with an interpreted version and worry about compilation later. Let's see, roadmap. So that's the basic, like, long-term plan. And bootstrapping just means essentially implementing the language in itself. So rather than whatever language I end up using right now, once I have a version of Korat working in another language, I can use that to build a Korat compiler in Korat, compile the new compiler with the original, and then just cut the original language out of the process entirely, so Korat is made in Korat. That's like a long-term down the road goal. Let's see. Do I have... One second. Let's see. How can I... Sorry, messing with Discord stuff, trying to get everything set up. It's been a long time since I streamed. Activity status. You know what? I'm just going to go do not disturb and change my status to that ought to do for now. So, post optimization, what I'd like to, well, we can work on that later. And somewhere in here, standard library. This is the long-term roadmap. Oh, I should probably explain where the name Korat comes from, actually. There is a existing programming related project called Korat, but it's like a Java testing framework or something, so I'm not too worried about the overlap. But a Korat is a particular breed of cat, which, since it's a concatenative language, is a bit of a pun. Let's see, name comes from the breed of cat called a Korat. Ta-da! Alright. So I think with that we can kind of just jump right in. The one thing is I need to decide what language to use. So what can we work with here? I know Porth is currently implemented in Python, which would be fine. But I'm like thinking through the list of languages I know and like which would be best for this. Because all of this is planned to be temporary anyway. So I think I might just do TypeScript. You know what? Yeah, let's do TypeScript. That should make things fairly easy. And let's pull up in the terminal. So we're going to need to split that. TSC watch. That is not how that works. Right. -- watch. Of course. Why are you like this? TSC-w dot. Will that work? There we go. That works. And here I'll be able to run it. So, no, that's not what I want. What I'm kind of want is font size for this workspace. I want the terminal font size to also be 24. And we'll pull that out a bit. Cool. And actually, one second, real quick. I'm going to tweak my bash RC a little bit because I don't really need the path, and that's going to take up a lot of screen space. So for the moment, I'm going to do this. I think that should work. So then we just quit. Ah, that's why that wasn't doing what I thought. Hey, Nikki. Yeah, this is... I've had this set up for a while, but I haven't actually gotten around to streaming using it, so... So what I actually want to do, instead of doing it that way, I want to... Thank you. The avatar maker I used doesn't have a ton of options, and this was the best one, but it worked out nicely. What part of this is putting the path in there? I think it's the /w. So I can just... Let's do that. Awesome, that's almost what I'm looking for. There we go. That should be a little bit better. There we go. That won't take up as much screen space. Just a temporary change. That would be nice, yeah. It would be nice to get a more complex texture on this. Let's see. So, let's do... All right. So we are going to be making this in TypeScript for now because it's something I'm very familiar with. So let's just do that. And that should be good. So the question is, what do we need for this? And you know what, I'm going to be using Deno for this specifically. So Deno run -a Korat.ts. Cool. So I can just page up to that whenever I want to run it. Let's see. So if we just do like console log, this is a test. Bada bing, bada boom, we have code running. So, one of the first things I'm going to do, and this is something I actually picked up from Tsoding, the other streamer who's making a similar language that I'm taking a lot of inspiration from, is he does something I would call assert-based programming, which a lot of people neglect asserts as a tool in programming because they're seen as more of a debugging thing. But in this case, that's kind of exactly what he's using for, but he doesn't take them out or anything like that. He throws in intentional errors that check certain things to remind himself to implement stuff. So when he wants to do something new, he can like add the most basic piece of it, and then all he has to do is follow the errors, which I think is actually a really cool way to do that. So really all I should need to do for that is just give myself a little utility function here. You know what, we'll actually make it a proper function. If not condition, throw message, or, well, and actually we're going to do new error message, or we'll do, so unfortunately JavaScript doesn't have a built-in assertion function, which is why I need this. So that should do fairly nicely. So if we just assert false with your feet stink or something, and we run it. Ah, right. Okay, that is my bad. So I switched over from regular JavaScript and forgot that I need type annotations in TypeScript. Uncaught error, assertion failed, your feet stink. Perfect. That is exactly what we need. So I'll just do document this real quick. And we need to do that. All right. How readable is that font size on screen? Would it be too much to make it a little bit smaller, or is it like bare minimum right now? Because it's alright enough for me, but if it were a little bit smaller, it'd feel better. Whatever. Yeah, you know what, let's go... Let's try 20 and see how that goes. Yeah, that feels nicer. Alright, so... where do we start? The first thing we need let's see. And what I'm actually going to do is make myself a quick little shell script to quickly run this. So Korat, and eventually this can be swapped for something. And we'll just do deno run -a, and let's see. Dash get all arguments. Perfect. that should do. So if I do that, I should be able to do, well, actually, deno dot and yeah, we're gonna have some issues with that. Do I have the, yes I do. I need to go into my settings and enable it for this workspace, don't I? Workspace, deno enable, there we go. That's better. So, oh, it's just args, okay. Not argv. And we'll do like that. So if I do Korat, this is a test. Ah, right, chmod. Kit resolve module. Oh, right. I need to actually shut up. I need to actually tell it it should be running Korat.ts. There we go. That's better. Perfect. Okay, so the first thing we need to deal with when we're trying to make a programming language is just straight up lexing the splitting the long list of random characters into usable chunks. It's a process called lexing. So real quick, what I'm going to do is let us see. Like so, and I'm going to if args.length is less than 1, no, actually I can just assert args.length is greater than or equal to 1. No, I don't want to do that. Because this should be user-facing. So we will throw there we go. And otherwise we will do deno.read text file. And we will await that. Args 0. And I'm actually just going to do that. Okay, so we've got the text of what we want to interpret, and for now I'm just going to console log that. So we will make a new file, test.kr. Let's do that. And let's do something like 1015 plus print. So that's somewhat similar to the actual how this language is going to look. Okay. Because I still never call main. There we go. Alright, expected file path to interpret. I'm actually not... Okay, for one, I'm going to make this synchronous. There's no reason to have it async. Give me one sec. Getting a bit hot in here. Okay, so what we want to do with that is how do I just straight up exit? Is it just deno.exit? Yeah, it is. Okay, so you know what? I don't need that. That's just getting in my way. Function. And we're going to, let's see. Console error message and deno exit. Then here, instead of throwing, I can just kr throw. And if we assert false, cool. Something like that ought to do. And perfect. So instead of throwing anywhere, I'm just going to kr throw because I don't want to deal with the automatic error formatting. At least on user facing stuff. Cool, expected a file path to interpret. So we can do test.kr. Awesome. So that's our first step, is just load in the text of the file. Now we actually want to write our Lexer. So I want to build this right. I have a tendency to build my Lexers very top down. I just sort of throw in stuff until it works and then I fix it later. But here I think I'm going to try and do it a little bit more diligently. So let's see. What tokens are we going to need? We're going to need a number, string, word, what else will we need? Number, string, word. You know what, I'm not going to do that quite yet. I'm also going slower than usual because I'm not used to talking through my thought process out loud. We'll get there. So the Lexer needs to take the program and split it into a list of tokens. So we'll have a token array, then type token. Token is going to have a location, which will be a tuple of numbers representing its place in the file. It's going to have text of the token, and it's going to have a type. What should the type be? Yeah, we need to do enum token type num string word. We'll work on that more later. Oh, keyword. So that will be a token type. And I also want to, let's see, TypeScript enum. Forget some of the semantics here. I don't use enums in TypeScript very often. Let's see. There's a reverse mapping, which is good. Okay, so what I want to do is I want to okay, so for now let's have this return that, and we're going to assert false not implemented. So if we lex the file instead of just, and we'll actually console log the lexed file instead of just logging the file itself. All right, that's exactly what we wanted. We got a not implemented exception, which I realize now is a little bit behind my head. Sorry. Can I swap those? Yes, I can. Perfect. That is super helpful. So I can kind of put this up here a little bit, I guess. Let me look at OBS for a little bit. There we go. That's a little bit better. So what's the first thing we need to do? Well, in this language, for the most part, things are just going to be separated by spaces. But there are situations in which I want to not have you have to do that. We'll start with that assumption for now, and I can work it back later. Because making space is no longer required is a lot easier to do than suddenly making them required when it comes to porting up code that's already been written. So, essentially what we want to do, I think I want to, while program.length, I want to okay, so we're going to take the word as from 0 to the index of a space. Can't index of, you know what, no, split by a regex, because that will give us more flexibility to do something like a general whitespace split, and we'll do that. And we'll max it at 2, and we just want to get the first one. Will that work? Yes, but then we need to set the program to a slice of the to a slice of itself from the length of the word, and trim that. Then we need to actually analyze the word we've pulled out, but for now we will do that and just console log the word itself and the program. So let's do that. Okay, so we pulled out the 10 at the beginning of our program. That is good. Now we need to actually analyze the structure of that. And for now I'm just going to keep a let tokens equal a list, and we will return tokens. Cool. So that should essentially what I'm trying to make is a programming language. So it's going to be a concatenative stack-based language, which essentially means that the entire program execution is going to be structured as a stack. So if you see something like this 10, 15 plus print, in something like JavaScript, you might, or like Python, you might say print 10 plus 15. But these two lines are equivalent, just in different languages. So how it actually works, if you think of like a stack of paper, you put something down, you put something down, you put something down, and you can only take things back off the top. It's actually the same way that tracking where functions should return from and to works in most programming languages. But we're using that for all of our program data instead. So when we're executing this 1015 plus print, we push 10 to the stack, so our stack would be something like 10. Then we push 15 to the stack, so now we have 15 on there. Then we take plus, which pops both of those off the stack, adds them together, and pushes the result back to the stack. So now our stack is 25, and then print pulls that off and outputs it. And that's kind of going to be the execution model for the entire programming language. Everything goes through the stack, at least until further notice. Rather than having something like this, where we have to essentially, with something like JavaScript, you have to deal with order of operations, and it gets really messy, whereas the order of operations in a concatenative language, and particularly stack-based ones, is just left to right. Makes it very, very simple to read and write. It's just a little unfamiliar. it gets unwieldy because people aren't familiar with how it works. So, and there are a bunch of other languages that are similar to this. Probably the most well-known is Porth. And there's another streamer who is making a similar language called Porth. His name is Tsoding. And so there's a link to that as well. I'm taking a lot of inspiration from Tsoding and his Porth project, but I'm kind of coming at it from a different angle, where I'm looking at higher level code and starting essentially from a different angle. So I'm coming in at it from, I want to get this language to work, and I want to be able to write useful, interesting, high-level code in it before I start dealing with actually pulling that out so that you don't have to ship the entire language with your program. Whereas he's kind of doing this low-level, bare metal kind of thing. Really, really cool stuff. But I'm essentially coming at a similar idea from the opposite direction, if that makes sense. So essentially what we've got at the moment is we've got one word being pulled out of our program. And that's basically just split at spaces. I'll do more complicated stuff around that later, and actually fairly soon. Strings are going to be interesting to implement. But for the most part, anything separated by spaces is its own chunk of code. So what I've done is just pull out the first space-separated chunk so we can look at it on its own. So the first thing we need to do is... one big thing with Porth is that Tsoding is trying to bootstrap it, which means essentially the language will eventually be implemented in itself. He's writing a Porth compiler in Porth, which is really cool, and I'd like to maybe eventually do that with Korat. But one of the things he's done is he's designed the temporary Python compiler in a very straightforward and almost dumbed down kind of way so that it's easier to re-implement in Porth. And to some extent, I am going to do that with Korat, but not to the same depth. I'm going to be using a bit more clever code in the original implementation, generally speaking, because I can always strip that back out later, and it makes it easier to get going quickly. So, we've pulled out our first word of our program, and we need to see what type of thing it is. So, I'm just going to say if word dot, let's see, what do we have to work with here? Let's use a little bit of regex, because that'll make things nice and easy. So, if all of it is digits, and I'll worry about, I'm actually going to make that integer. I'll worry about floating point numbers later. And we want to test that against the word. So if it's all digits, well, if it starts with a digit, we want to treat it as a number if we can. So essentially what we want is if... Okay, what I'm going to do, the reason I'm doing this way, the reason I'm testing it twice is I want the first to catch anything that starts with a number. The second is going to check that the entire word is all numbers, because if it starts with a number, we want to treat it as a number, but we don't want to confuse things that start with numbers, if that makes sense. I may walk that back later, but for now, anything that starts with a number is going to be treated as a number, and if it's not all numbers, it's going to error. Expected, let's see. Tokens beginning with a number must be integers. Must be valid integers. So that will do for that. Then we want to push in a token, and that is one thing, is we're not at the moment tracking the location, so we need to do that. And that is actually one thing that I need to be careful of. Line 0, column 0. Actually, we'll just do location equals 0, 0. Okay, so I don't actually want to trim that. We'll work on dealing with leading whitespace in a second. So we want to push in the location. And of course I need to number because TypeScript. And we want the type to be token type.int. And the actual text is going to be the word itself. So then we need to we need to add the length of the word to the column of the location. And I'm going to do that up there. No, I'm not. Okay. So if we do like so, cool, we've got a that's what I missed. So we actually need to do that because JavaScript is silly. Is there a better way to do that? That's actually kind of annoying. Let's see. You know what? It's fine for now. I can work on swapping that out later if I need to. So yeah, that parsed our 10 correctly. And pulled out and it made it down to the not implemented. So that's exactly what we want. And I'm actually going to stick a continue at the bottom there. So what I need to do here is, if the program starts with, I don't actually want the G there. If the program starts with whitespace, test program, we want to handle increasing the line number. So that actually should be as simple as let lines equal program.split, and we'll do /r/n. Okay, so we split at line breaks. And actually, we'll do this a bit of a different way. Slice from 0 to the what does search do? Find the first substring match. That's not what I want. That's what I was going to do. We want to trim left. Dot length minus trim left dot length. So if we then program equals program dot slice lead dot length, and we log out lead dot length and the remaining program, and we'll comment that out for now. Wrong console. Okay. Okay, cool. So the lead length is 1. That's perfectly okay. Alright, but what if I put a line break in there somewhere, or so like some random spaces? Okay, that still appears to be working correctly. So what I need to do is then let's see. I need to split the lead at line breaks. So Let's see. Lines equals lead dot split, and that needs to be a let. Split at line breaks. Lines. What does that give? Okay, awesome. So what I'm dealing with here is if lines.length is greater than 1, so if there was a line break in there, we're going to do one thing, otherwise we're going to do something else. So if there were no line breaks, we just want to increase that by lead.length. So that's really simple. Actually, there's probably a better way to do this. So what I'm actually going to do is lead dot index of /n, because that is the index, the location of a line break. And if that is not equal to -1, so if one was actually found, then we split the lines. That should save a little extra. And we increase the line count by 2, 3, 4. Lines.length -1, and we set the column count to lines.length -1 dot length. So what that should do actually, you know what? If there's only one, it'll increase. Oh, I can just pull this out of that check entirely. Okay, so what that should do is split that leading white space around line breaks, increase the line number according to the number of line breaks it found, and then set the column number to the remaining length of the last line. I think that should work. So if we log out tokens, we're still getting... Oh, okay, because we only handled... Yeah, that makes sense. So if I put a... Oh, that's perfect. That works like a charm. Cool. That works just about perfectly. So let's just handle leading white space. And then we need to handle the next thing, which is general words. Actually, I'm going to move this to the top here. So if this is actually going to be our last case. So we'll just okay. And right, so our base case is just going to treat it as the entire word as a chunk. So we're actually going to do this. Unimplemented token format plus. Perfect. That's exactly what I wanted. So, let's see. Enum keywords. What keywords are we going to have? For now, we're going to have none. And let's see, TypeScript enums. Just refresh myself real quick. If word in keywords, then we're going to tokens.push. Location is location. Token type dot keyword. And text is just word. Alright, so that pulls out our keywords. And we'll continue from there. If it's not a keyword, and we'll handle strings in a second, we want to just tokens push type just a regular old word. That's what we're going to treat as an identifier, which will let us do all sorts of fun things like using symbols in identifiers and stuff, which a lot of programming languages don't support for very good reasons, but this one doesn't have a lot of those reasons. They don't necessarily apply. So I think we can pull that out. And here, if word dot starts with a double quote, we want to strings not implemented. Cool. Do I want to have character primitives? That is a question. That is a question indeed. The answer is, for now, I don't think so. So if we run this, what we should get out... Oh, that's interesting. Okay, That is very interesting. And something I need to actually do here is I need to assert token type dot let's see. It's an object. JS object number of keys. Find the number of keys in an object. Okay. That makes sense. So what I'm actually going to do is, should I do that? Not for now. Object dot values or keys token type dot length should be equal to 4, because that's the only exhaustive Lexing of token types. Perfect. So if I implement a new token type, that will throw and let me know, hey, you haven't implemented all of your token types. I'm actually going to put that right up at the top there. Cool. So that is properly Lexing our program at the moment. Why is that not working right? So log token type. Ah, reverse mapping. That's why. Okay. So that's slightly annoying to deal with. How should I deal with that? I think the best way to deal with that would just be a simple function. So function enum size enum should just return the object dot keys enum dot length divided by 2. Number. Why are you giving me errors? Why are you giving me errors? That doesn't make sense. That's weird. What in the heck? Oh, right. It's because enum is a keyword. That's why. That makes a lot of sense. So then I can just enum size of token type is 4. And that should let me, cool, that works perfectly. And here, if not program dot length break. Cool. So that deals with the leading whitespace ending us up with empty tokens at the end. So, strings. How do we handle strings? I think what we need to do is make a little interior function, and I'm just going to call it next, and it should do this pulling apart. So then we just let word equal next. Because what we can do then is, okay. So if our word starts with a double quote, we want content to be an empty, we want content to be word dot slice one. So that should take the quote off. While not word dot ends with a quote, so while the current word doesn't end with a quote, we're going to that's actually not quite going to work. So I'm going to pull this back out. I'm not going to use next that way. We are just going to program.split, and it's going to be a we want something that is not a forward slash, because that should escape. We want that to be a look. We want a negative look behind. Regex 101. 1 second. JavaScript look, a negative look behind. Okay, cool. So negative look behind for a backs, but that gets back into that problem of how do you deal with escaping slashes? I dealt with this problem in the last Lexer I built too. It's a really annoying problem to deal with. So I think what I actually need to do is just slice 0 to program.index of a quote. And what I'm actually going to do is while program.length content plus equals that, then if content dot okay, we're actually going to do while content dot ends with a /. No, that doesn't quite work either. Shoot. Okay, let's see. How do I want to handle this? Program equals program.slice content.length. Not content.length. The index of that plus 1. So if we content and like that, it's not going to do anything because there are no strings in this. So hello world. All right. Strings are a pain. Strings are indeed a pain. How should we do this? Okay, I should probably explain the problem I'm having. Essentially, the problem is I want to be able to put a \quote in the middle of a string and have it stay as a literal quote in the string instead of ending the string. But if I \, it should, essentially if I have an even number of backslashes, it should be escaped backslashes. If I have an odd number of backslashes, it should be escaped backslashes up to an escaped quote. So my problem essentially is that I need to handle shoot, how do I do this? I've done it before, but always in a very different style of Lexer. I think for now, I'm just not going to support escaping. So I'll just do to slight Yeah, this is a really actually a really tough problem to deal with in these sorts of situations. Because it's pulling out the string correctly. Like, if I put the quotes back around it in the debug output, It's grabbing the content of the string correctly. But if I try to put an escaped quote in the middle of the string, it treats that as the end of the string instead of as an escaped quote. So what I really need to do is if content.place all double backslashes with nothing, just for now, ends with a backslash. Let's see. How should we handle that? Because if it ends with a backslash, I want to continue. So content plus equals a quote. And otherwise, we should break. Will that work? And I actually want to not do that. Well, no, I want to do that, but not that. Okay, that's not quite it. Let's try that. Oh, that's perfect, actually. So that's exactly what I wanted. So break, and then we can just do that. Like that. If we take out that assert and we do that, token type string, and the text should be content. And then we need to continue. That should properly bring in the escape. But it still has the slash in the middle. So I actually want to content.length -1. Right. So content equals content.slice 0 to -1 plus that. So we want to actually replace that with the quote. Then if I do an odd number of slashes, Right. What I actually need then is content dot replace all double slashes with just slashes, because that should unescape them. Perfect. So we have an escaped slash and an escaped quote, and we have a slash and a quote in our actual string output. And I'll put a strings to do other escape sequences, like so. And this keywords and other words. And one other thing I want to do is I want to also support single quote strings. So anywhere I'm using quote here, I want to replace with word 0. I want to start from there, and I want to replace. That ought to do it. So that's actually a surprisingly simple way of handling strings. And it should work the same if I take that same line and just replace all of the quotes with single quotes. Yep, that's still working fine. And if I put a quote of the other type in the middle there, it should just work. Awesome. That is exactly what I was looking for. What if I actually then, real quick, console log the actual string. Okay, cool. That is just an artifact of the deep console log. And I'm going to pull this to do down to there, because that's where it's actually relevant. So I think that just about handles the Lexer. So, long story short, we take in a program as a string. We look through the tokens. We look we set up a list of tokens and our current location. And then while there's still like length in the program, we chop off leading whitespace and handle the location tracking stuff. Then we take the first space-separated word, check it for integer, string, keyword, and if it's not any of those, we just push it as a regular old word. For now, I think that should work. The one other thing I want to do is comments. So I think I'm going to do hash comments. So if the word starts with a, do I want to do hash? Do I want to do hash? Yeah, I want to do hash. If it starts with a hash, then we set the program to be equal to the program.slice from the index of /n. So that should jump to the next line break. And from there, I think all I should have to do is set loc0 plus equals 1 and loc1 equals 0. I think that should work. So if I put in a comment, all we should see is those go up by 1. But we've still got... Right, because I didn't continue. There we go. We have comments. So line 4, we have... that's interesting. Line 1 we have plus, line 2 we have print. Okay. Yeah, because that will include... There we go. That's better. Okay, so now we have comments. And that, I think, should just about do it for the Lexer for now. We've got support for ints, strings, keywords, and other words. We don't have any keywords implemented yet, though. So I think I'm going to call the stream there for now. I'm going to work on designing, like figuring out what I want in the language a little bit more before next time. And we can start implementing some actual parsing and execution stuff. Because right now, this is really just pulling apart the program itself into usable chunks, which is important, but not all that interesting once it's done. So, thanks y'all for watching, and I hope you all have an amazing day. Bye all.